Hi, my name is Matt McConnell. I'm the Lehigh Valley Sierra Club chairman. This is the Buck Mountain mine drainage site up on the mountain here. This is the outflow from the tunnel, Buck Mountain 2 tunnel, that drains water that dewatered the coal areas. And this stream flows down across the Buck Mountain Road here and eventually ends up in the tributary of the Buck Mountain Creek, which flows into the Lehigh River at Rockport. So the mine drainage remediation site is up on the mountain. It's a flushable limestone bed that is intended to remove aluminum from the stream. This is a low pH water, 3.5 pH, and the aluminum content is 7 parts per million. 7 parts per million is 10 times above the acutely toxic level for aquatic life. So this stream is the source of aquatic toxicity that goes on to contaminate the Buck Mountain Creek, which flows down into the Lehigh River. And in this project, we're assessing the aluminum content along the way as this travels toward Buck Mountain Creek, or toward the Lehigh River. So we're checking the water quality parameters here. Hi, now we've moved to the 10 Points Road location, which is the first road overpass of the tunnel discharge stream, which is flowing this way, and on its way to the confluence with the Buck Mountain Creek tributary, which is about 100 yards in the forest here. It flows in. The water at this point is pH 4.3 and the aluminum content is 3.01. So here we see that the aluminum has been reduced from the 7 parts per million content at the tunnel outflow because there's been dilution from a marshy area that is coming in. They're unnamed tributaries, but that dilution effectively 50 to 1 dilution reduced the aluminum content in half. But it's still 3 parts per million is still quite a ways above the 0.7 part per million limit for acute toxicity to aquatic life. So as a result, this stream is devoid of aquatic life. Anything with gills cannot survive in this water. And the Buck Mountain Creek headwaters. This is an exceptional value trout creek in here with wild reproducing trout living in this stream. The water here has very good water quality. This flows into the forest here and meets with the tunnel discharge flow, and the stream at that point is called Buck Mountain Creek. So if we take a look at the stream a little closer, oftentimes you walk up to the stream and you can see fish darting along. Yeah, there goes a trout right there. So if we just take a look in the water, oh, there goes a frog. Okay. You can see how the water is pristine. You've got a nice gravelly bottom suitable for trout spawning. So the conditions of the stream here at the Buck Mountain Creek headwaters is 6.63 pH and 0.014 parts per million aluminum. So essentially zero aluminum. Low pH, it's actually got very low specific conductance, 29 micromoles per centimeter, which is very low. So it's a very clean stream, full of natural reproducing trout that cannot access the main stream that goes back to the Lehigh River because it's a toxic barrier. Okay, so now we're at the Stagecoach Road crossing of the Buck Mountain Creek. The Buck Mountain Creek tributary was about 2/10 of a mile upstream here. It tied in, and now that joined the flow. You can see the flow is significantly more now. Again, it's toxic to aquatic life because of the aluminum content in the stream. So the concentration of aluminum at this point is 1.15 parts per million aluminum, and also a pH of 4.85. So as long as the pH is below roughly 6.5, the aluminum will stay in solution. So here it's 4.85, so the aluminum is still in solution. Again, the toxic level is 0.7. The acutely toxic level is 0.7, and here it's at 1.15 parts per million. Okay, we're now at the Lehigh Gorge Road overpass. So the stream flows underneath Lehigh Gorge Road here. Now we start to see that the water starting to cloud up a little bit. That's because pH is now coming up enough for some of the aluminum to start coming out of solution. You can see the haze in the water. So the water quality conditions here at Lehigh Gorge Road are 0.64 parts per million aluminum. 0.64 is just slightly below the 0.7 parts per million acutely toxic level, and the pH is 5.3. So it's still, the aluminum is still kind of in solution, but you can see the volume of water is significantly higher now than it was. That's because there's miscellaneous unnamed tributaries flowing into the stream and diluting. So this stream is still devoid of aquatic life. It's pretty much right there at the acutely toxic level of aluminum. So again, it's a massive shame that this otherwise beautiful creek can't support any aquatic life. Now there's also the concern over other wildlife that may drink the water. Mammals like fox and deer, bear, fisher cat, even mountain lion up here can get sick from drinking the aluminum. But the main toxicity is to aquatic life, anything with gills. Okay, now we're at the confluence of the Indian Run tributary and the Buck Mountain Creek. This is the impaired aluminum stream, and this is the Indian Run, and we're going to take some measurements on the aluminum and pH of this stream. This is the combined flow flowing down into the Rockport confluence of the Lehigh River. We're just a few hundred yards from the confluence of the Lehigh. Okay, so we're checking the water quality parameters on the Buck Mountain Creek side of this this junction here, and we just finished taking the water quality up there on Indian Run. So the water on the Buck Mountain Creek coming into this confluence here is 0.79 nitrate, 56 degrees Fahrenheit, 91 micromole specific conductance, 15.4% saturation oxygen, pH is 5.76. Indian Run, 0.88 nitrate, 56 Fahrenheit, 48.7 specific conductance, 114.5% oxygen saturation, and 6.95 pH. So this is where Buck Mountain Creek crosses Lehigh Gorge Road, and then it heads downstream here to the Lehigh River at Rockport. And we're going to go down there and get our aluminum measurements downstream a little bit. That little tributary coming in at the left, that's Indian Run. So this is our aluminum analysis method. Basically it's a colorimetric method where you prepare a blank and then you prepare a sample. And basically you're looking at the color differential between the two, and use the colorimeter here to make your measurement. So right now we're waiting for the color to develop. It's a 15-minute timer, so we've got a few more minutes to go before it's ready to measure. Okay, so the timer's up, so we measure the blank, and we have to wipe it off with wipe it, stick it in, and hit 0. That 0 is the instrument, so that is 0. And take and wipe the cuvette with the sample on there, and we hit read. 0.278 parts per million aluminum in the Buck Mountain Creek here at Lehigh Gorge Road in Rockport, the confluence of Indian Run. 0.278. Okay, so the Buck Mountain at the confluence of Lehigh River is 116.6% oxygen, 0.85 ppm nitrate, 6.42 pH, 82.9 specific conductance. And there's the Lehigh River there in the distance. So we're here on the Lehigh River, just above the confluence with Buck Mountain Creek. Checking the water quality conditions, and they are 117% oxygen, 0.89 per million nitrate, 7.0 pH, 67.3 specific conductance, and 61 degrees Fahrenheit. So that's the Lehigh at the upstream of the Buck Mountain confluence. One thing you notice when you're along the banks of the Lehigh River is there's always some of this stuff laying around. That would be anthracite coal. The root of our pollution problems on the river. The mining extraction of anthracite coal. You find that stuff here and there along the river. One of the other things you can notice is here's a a stonefly nymph casing. He crawled all the way up from the river to molt here on the tree. Usually you'll see those stoneflies on the stones. Hopefully this work will help us get the Buck Mountain Creek cleaned up sometime in our lifetimes. And so here is Buck Mountain Creek. One last look. Looks great, but has no aquatic life in it. Very sad. And people don't realize it, and that's why we're doing this project. pH starting at the tunnel went from 3.8 and aluminum of 7.1, and then at 10 points it was 4.32 and 3.01. Stagecoach Road, the pH was 4.85 and aluminum was 1.15. Lehigh Gorge Road, pH was 5.3, aluminum was 0.64. Buck Mountain Creek at the Indian Run, which is probably within about 200 or 100 yards of the Lehigh, it's 5.76 pH and 0.278 aluminum. Buck Mountain Creek at the Lehigh, just before the confluence, it was pH 6.42 and 0.238 aluminum. The Lehigh River itself was 7.0 pH and 0.049 aluminum. The Buck Mountain Headwaters was 6.63 pH, 0.014 aluminum. Indian Run was 6.95 pH and 0.0 aluminum. Now here's a topographical map of this is where the tunnel is, the Buck Mountain 2 tunnel. This is all strip mine up here, and the flow comes down the hill, then it crosses Buck Mountain Road here. So this is a sample point here. This is where we measured 7.0 aluminum, or I'm sorry, 7.1 ppm aluminum. And then as we came across, there's some dilution here that comes from a marshy area. And then this is 10 Points Road here, and that's a sample point. There we measured 3.0 ppm aluminum. And then shortly after that, there's the Buck Mountain 2 comes in. The Buck Mountain Creek itself comes in here. And our next sample point was all the way down here at Stagecoach Road. And that was 1.15 ppm aluminum. And you can see that also gets diluted by this stream. Then it goes on to Lehigh Gorge Road here. I'm sorry. It comes down to Lehigh. Let's see. Lehigh. Yeah, this is Lehigh Gorge Road here. And there the sample was 0.69 parts per million aluminum. Then the stream continues on all the way down to Rockport, where Indian Run comes in. And right before the Indian Run confluence, we have 0.278 parts per million aluminum. And then right down here at the confluence of the Lehigh on the Buck Mountain Creek, there we measure 0.238. The Lehigh River itself, we measured above this at 0.049. Back here on the headwaters of the Buck Mountain Creek, before it crosses underneath Buck Mountain Road, we measured 0.014 ppm aluminum. And the Indian Run down here, we measured 0.0 parts per million aluminum coming in on the Indian Run. So this is the Lehigh River coming down around, kind of loops this way. It's got this big loop comes across. This whole area up here is strip mining up here on the top of the mountain. So this tunnel that was put in here was to dewater this area. So now we have this impaired water coming down, which is the source of all the pollution that kills the aquatic life in this entire stream. Now this is the source of the tunnel, the source of the mine drainage coming in here. This is the tunnel phase. And this is the limestone, flushable limestone bed. And we have it filled with water here. And you can, if you look down into this this invert, you can see how crystal clear the water is down there. That's because this is before the aluminum is starting to come out of solution, because the water has to travel over the limestone before the pH starts to rise. But then if we get further downstream, you can see how much material is suspended in the water here now. This is outlet number 3, and you can see it's milky. I mean, it's so much aluminum in there because it's 2/3 of the way down through the wetland, and the pH is now high enough. So when the water is milky like that and it flows through the system, we really need to collect that aluminum. So we installed this filter system, and you can see there's 4 turbidity or suspended solids filter elements that get installed inside the storm basin. So once we get the flushable limestone bed back in service, we'll be getting the benefits of removing this aluminum from the water.